Section 26, question 4. Quadrilateral ABCD with angle ABC 90 degrees is shown below. So a quadrilateral is just a full-sided shape. AB is equal to 4 metres, BC is 6.2, C is 7 metres, and AD is 5 metres. Question A says find the length of AC. Now for me that's definitely going to be a Pythagoras question, so I'm just going to put a line down there. So it's the hypotenuse I'm looking for, so I'm going to add for this one AC squared is equal to 4 squared plus 6.2 squared. AC squared will be equal to 54.44. So AC will be equal to the square root of that, and that is just going to enter that into the calculator. To one decimal place, that's 7.4, and the units are metres. So I'm just going to enter that into the diagram. Part B says calculate the size of angle ADC, which is this angle here. So I would immediately identify that now, after getting a bit of support from part A. I would immediately identify this now as a cosine rule for an angle question. So I've got three sides I'm looking for an angle, and I would interpret that as cosine rule for an angle. Remember, your sine rule and your cosine rule formulas are at the formula sheet. So the angle is at D, so it's going to be cos D equals A squared plus C squared minus D squared over 2AC. So cos D equals, and I'm just going to go back and get that information. So A squared is 7 squared plus C squared is 5 squared. Take away D squared, which is 7.4 squared. So cos D is equal to 7 squared plus 5 squared minus 7.4 squared all over 2 times 7 times 5. So I'm just going to enter that into the calculator. So 7 squared plus 5 squared minus 7.4 squared. Divide by the bottom, and that will give me 0.274. So the angle D is going to be equal to cos inverse 0.274. Enter that back into the calculator. And that will give me 74.1 degrees, and that's the final answer to the question. Section 26, question 5. Telegraph pole is 6.2 metres high. The wind blows the pole over into the position as shown below. AB is 2.9 metres, and the angle ABC is 130 degrees, calculate the length of AC. So looking for this bit here. Now the pole was 6.2 metres long, it still is, it's just that it's broken now, so that section of it is 2.9. So to get this section over here, I would just do 6.2 take away 2.9, which will give me 3.3. I'm going to fill that in. I'm looking for this side here, which I'll call small b, that's small a and small c. I've got two sides with an angle sandwiched in between. I'm looking for the opposite side, that's cosine rho for the side. So that's going to be b squared equals a squared plus c squared minus 2 ac cos b. So I'll just start to enter in information for that. So it's going to be b squared is equal to 2.9 squared plus 3.3 squared minus 2 times 2.9 times 3.3 times cos of the angle, which was 130 degrees. So I'm now just going to enter that into the calculator. So b squared then will give me 31.603. So I've got b squared, and I want b, so I'm going to take the square root. So square root of 31.603 and that will give me 5.6 metres. That's the final answer to the question.